Hi, I'm Kata Martin, and I'm the product lead at CarbonPlan. CarbonPlan is a nonprofit research organization that aims to improve the transparency and scientific integrity of climate solutions through open data and tools. We're partnering with LEAP to build web visualization tools to promote access and exploration of climate data. We're hoping that these tools will be useful both to the LEAP research community as well as a broader audience of users that will consume and make decisions from these data. First, we're building a data catalog to promote the easy discovery of data sets being used and produced at LEAP. This is an early demo of that catalog. You can see a data set that was recently added. It's a sea surface temperature data set, and it was added by researchers at LEAP. We also have some example data sets that we created for the purposes of this demo to show off this data catalog, and also a map visualization tool, which I'll show you now. We're building this map visualization tool to make it easy to explore any publicly hosted geospatial dataset. We believe that this can help during the research process while scientists are understanding and diagnosing their datasets, and it can also be used to share research outputs with the broader community and allow users to explore and interrogate the data. This is a maximum air surface temperature dataset from CMIP6, which models temperatures through the end of the century. I can use the tool to pan through time and look at the maps as they change. I can also zoom around and pan through space. I can also use this display panel on the left to change the way the map is rendered. So I can update the projection of the map. I can change the color map. And I can change the color range. I can also generate time series using this plots panel, also on the left-hand side. With this, I can drag around a point and look at time series over space. I can also zoom in, grab a point of interest, and look at the time series. Notice the longitude-latitude pair up here. I can also download a CSV of the data underlying this time series. This would allow me to, if I take this data into Excel or Google Sheets, I can reproduce the time series or look at the numeric values underlying this plot. Here's another data set that maps annual precipitation data, also from CMIP6. I'm showing this to underscore that this is a generic tool that can handle different data sets. So we can make all the same customizations for this data set that we made for the temperature data set. And here's a final sample data set that illustrates how an analysis might combine multiple variables to derive a metric more relevant to humans. In this case, we're showing an index that combines temperature and precipitation, both of which we just saw, to determine where agricultural corn growth is viable and how that will change in the future. To produce this data set, we look for places where the minimum and maximum daily temperatures are high enough to support growth, with more growth potential shown in these brighter greens and yellows. We also check to see if there's enough precipitation, meeting a 25-inch threshold in order to facilitate growth. If that threshold isn't met, those areas get masked out. It's not a particularly sophisticated analysis compared to the kind of research that will be coming from LEAP, but unlike just temperature or precipitation on their own, it's a metric that has consequences both for an important business sector as well as general issues of food availability. We can use the tool to demonstrate some key trends in the data, namely that corn growth expands northward towards the end of the century. We can zoom into northern Canada and see that areas that were previously too cold for corn growth when represented by black pixels, become hospitable towards the end of the century when they turn green. This is when those regions become warmer due to climate change. We can also look at the time series to confirm this trend. And we can contextualize the trend by comparing this to time series further south. As we move south, we don't see this trend, and instead we see growth viability stay more constant. This is just one of many metrics that we could define using the same canonical inputs. We could also derive things like fire and flooding indices. We were able to use the map visualization tool to explore some simple analyses on the fly, but this ecosystem of open data and tools also facilitates more in-depth analyses, for example, in Python computing environments. Here we have a Jupyter notebook that performs analyses over the agricultural data we just looked at. In this type of environment, we have the full flexibility of analytical and computational choices to support more advanced analyses. Here, we're generating new maps that capture the difference in growth potential from the model's beginning in 2015 to later years in the dataset. More positive changes in growth potential are shown in red, and we can see the same expansion of growth potential to the north in these maps as well. Negative growth potential changes are shown in blue, and this is where it will become harder to grow corn. This has all been a very quick tour of different views into the data that we're working with at Leap. Feel free to reach out to any of us working on these tools if you have ideas or want to learn more. Thank you.